Welcome to tree interaction within stands. The outcomes are able to define a forest stand, able to list the factors that influence a forest stand, explain the influence of competition within a stand, and that we would like you to provide examples of how forest stands are influenced by a variety of factors. This is the objective of this video. So the first thing we're going to be looking at in this course is we're going to be looking at plant interaction, and so we're going to be looking at what are the limitations of growth between trees as a group of trees. So that'll be the first little challenge we will have. So first we have to back up a bit in regards to what is stand dynamics. I'd like to talk about that. Stand dynamics is something which is, forest stand dynamics, excuse me, is something we have a hard time imagining as humans. You know, for a tree, a short-lived tree is 60 years. In human lives, well, we'd have a different feeling about if that is short-lived or not. But the truth of the matter is that we don't realize or don't consider the fact that there's a lot of interactions occurring in that forest which over time can influence the structure. Change is happening all the time. That is a guarantee. So first thing we want to do is look at what is the definition of a stand. And a stand is a forest stand is a spatial, continuous group of trees and associated vegetation having similar structures and growing under similar soil and climate conditions. So, for example, if it was a forest stand up north in the boreal forest on a sandy site, we may see a mixture of jack pine and poplar with an understory of bunchberry and some ferns, and that would be a stand. Okay, and then within that stand we may see that there actually is different stand structures. So a young jack pine stand, let's say young being 40 years old, would have quite a different stand structure compared to a jack pine stand of 120 years. And so those things all influence how trees respond to growth. Oh, excuse me. The first thing we want to look at then, therefore, is the whole idea of how does a forest grow? And in the past, what has happened is we had the perception, a lot of incorrect perceptions. And one of them is the idea of the superorganism. In other words, the idea that forest stands, are much like human bodies. Take out the liver and then the person dies. That's pretty well a guarantee. But take out a particular forest tree, will the whole forest collapse? Not so. It's a different approach. And the same time is the idea that everything wants to achieve old growth, and then once it gets there, it stays there forever. That's another incorrect idea. Or this whole idea of balance of nature, which is a kind of a vague term at the best of times. Does a forest always strive to have a balance of nature? And that has not been the case. What we have found over time has been that those ideas I just presented, is the idea of mutualism, that things work together. But the truth of the matter, a forest basically is a very competitive place for the vegetation that grows there. Whatever can take an advantage of the growing situation will. And how do we know that that's true, that mutualism is not the way, but competition is? Well, they've looked at different things. They've looked at logged areas and discovered, hey, after it's logged, a white pine stand may well turn out to come up as a poplar stand with a bit of spruce. Totally different. And we're not surprised about that now because we understand how trees interact and their competitive edge they may have at different times of their life. The other one is that as forests change because of the unfortunate situation of global warming, we're seeing species migrating more north. And MNR is actually doing careful analysis of seeing what compositional changes are occurring in our forests because of species migration. And why are they migrating? Because the more southern species can compete better in these in a more warmer climate. Therefore, as the temperatures rise slightly, some of the more northern trees cannot compete, and therefore the more aggressively competing southern species take a foothold. For example, black walnut could be found way north in Timmins someday. The other one is recently introduced species. Buckthorn is an example. That's a tree that wasn't ever here until about 100 years ago, and suddenly trees that have been here for 10,000 years can't compete against it. So it is competition is all about is how it works. It's not an idea of that just because you've been around for 10,000 years here in the one spot growing that it has an edge over an introduced species. No, it's all about competition. Disturbances and age distribution are also influenced by once there's a disturbance, it could be a downburst, a tornado, windstorm, ice storm. The species that come back are the ones who can take advantage of the best of that disturbance and outcompete other trees. So it's all about competition. So in here on this particular picture, we have trees competing in the understory. We have trees. These trees here are competing as they grow upwards with these ones here, and in actual these trees are competing with each other. So it's a very busy place, a forest indeed. And here's another example, extreme examples. What we have here, we have a wet location, and you can see we have the spruce coming in into the very wet areas, while the poplars and such are staying back a bit. They're not able to compete in those kind of sites, and they do try, and little trees grow and they die and they get outcompeted. So it's not a question of the tree can see, hey, there's some water, I'm not going near there. It's just a question of how far can it go before it gets outcompeted by another species. Another example on a very dry site, again both of these are up in the areas where you guys are doing your road layout. This is a rocky site, and here you see a little pine tree growing in a crack, very dry site, and it can outcompete other species which are trying also to establish here. And again, it's all a question of being able to be the regen strategy. What strategies do trees have so they can grow in different physical environments? Very xeric environment, very hydric environment here.